get started. Okay, so quick announcement. You've probably heard us talk about this briefly, but now that it's actually running and coming up next week, I like to advertise the AI Days Hackathon. We'll send all the links and stuff for sign up in the Discord. But if you sign up by next Wednesday, the kickoff is 9 a.m. and it's a 24-hour long AI related hackathon. You can either compete individually or in teams of 2 to 5. But the catch is that because it's an interdisciplinary hackathon, your teams must have at least 2 departments represented. So it can't all be just CSE majors, can't all be just CE majors. If you have that one friend who's like a math major and really into STEM and stuff like that, then they can definitely be on your team, contribute. We really want a lot of people participating because there is a total of $25,000 in the available prizes. There are about like 160 people signed up so far. So it looks like we'll have a great turnout, make it really competitive. And if you participate, you get free food. They serve you breakfast, lunch, and dinner since it is 24 hours. And you'll also get a free t-shirt and some street cred if you win. We also have open forms for signing up to volunteer. If you don't think that you're prepared for an AI related hackathon, but you still want to see how it goes and want to contribute, you'll also get free food and a t-shirt. So if you want to sign up for different shifts throughout that 24 hours, I will send the form in the Discord. And if you are conveniently in this philosophy class, is called Data Ethics and Technology, like I am, our professor is being very generous and giving extra credit for participation. And just real quick before Ryan kicks us off, next week we have the usual meetings on Monday, Tuesday, Wednesday for red team, blue team, and CTF team. And sorry, next week is not the career fair. I forgot to take that part out. But we have a GBM based on hardware reverse engineering with a graduate guest speaker from UF. So now we'll pass it over to Ryan.
Okay. Check, check. Hello. Okay. Um. Oh wait. Oh yeah, that's okay. That's chat. So, hey everyone. Yeah, let's get started. So, talk database shenanigans. Exactly what do I mean by that? So, what does this talk about? It's going to be covering a lot of different database or open source database implementations, specifically the data structures used to actually model the databases records inside of it, the values, algorithms used to interact with these various data structures, and looking at a bit of an unorthodox attack surface for these databases. Effectively, this is sort of like a side project that I did like 6 months ago. And this unorthodox attack surface, it is a database save file where the databases actually will save the contents to, so it can the data can persist. Oh, okay. Yeah, never mind. Yeah, it's a database save file. Exactly what is that? It's the file where the databases will save the contents to, so it can persist when the database shuts off. Not the best attack surface in the world, of course, and a lot of instances that attack surface you're not going to be able to actually reach. But there are a few instances in which it could be applicable, such as like if file permissions are read on a particular box, or if the database save files are stored on a box separate from the actual database server. And the thing that's a little bit more interesting is the reason why I looked at a lot of different database implementations is because you can actually do a lot of fun things at a lot of different database implementations if you control the database save file. So let's continue onwards. If you want, a lot more docs and stuff is available at this GitHub repo. Probably a lot more than I have time to go into. I was told I have 30 minutes. Is that correct? Roughly? Okay. Okay, cool. So first off, the first database implementation I'm going to talk about is SQLite. Has anyone, I'm assuming probably a lot of you have heard of it. Um, okay, Amber Alert. So you guys cannot see that. Okay. So roughly, actually, can you guys actually read this or no? Okay. So roughly, this is the structure of a SQLite record in its default state. Starts off with a value that's the total size of the record, followed by a record ID. Then you have the header, which is first comprised of a size value, which represents the size of the header. Following that, you have various values specifying the different types of data. And then after that, you will have the actual pieces of data for the record itself. Here is a listing of the various data types which SQLite has. A lot of integers of various byte sizes. You have floats, and then you have these down here, which is a blob and text. Those are effectively strings that SQLite can store. Now, for this, the reason why I have it as greater than or equal to 12 or 13 is the size value, well, the data type used to specify a string will also have the size value encoded using this formula right here, length equals this. The type value, that's the specific type used to model the data type. You take it, subtract 12, divide it by 2, drop the remainder, and that gives you the length. The reason why you drop the remainder, if this result is even, it's a blob. If it's odd, it's text. And yeah, and the reason why you drop 12 or minus 12 is because of the various values used for data types before there. Now, interesting thing about the SQLite save file, actually, this is when I'm going to start like actually doing demos and stuff like that. Do you guys want to take a pizza break or just continue going? Okay, you guys want food first. I don't blame you. Okay, yeah.
Honestly, y'all can get two. I expect more people to vote.
Well, hopefully. No, I am, yeah.
What super? Yeah.
Using Splunk and no, not realistically, we've been covering a bit about
delete and start your place.
So what we're trying to solve that case when you're like such a strat, like let's just like completely rebuilding kind of what the infrastructure or like let you manually locate every single network connection on this network. Yeah. I'll make sure to model our network strategy, our competition strategy based off of that. There's like having like completely destroy. Oh, for CCDC. Yeah. No, I don't know. Actually, wait, what? Like, what?
Design report. Yeah, basically gutted everything and gutted everything.
Yeah, just build everything with like the latest version, and there isn't like a web app that you have to like tell them like what you're gonna do with that.
Oh no, we didn't do that, but we did rewrite a lot of the stuff that was there.
So that's the thing. We have a lot more restrictions this time around in terms of what you can actually talk to them. Oh yeah, I heard you can see they actually made it. Like the version you got, you can upgrade or downgrade. Yeah. So it has like an literally have to run nowadays. So once it is authorized,
Yeah, I mean, that's not a box, it's a bag.
yeah. Yeah.
I think that bottom one really about let's see over mid-November. Wait, so you can't really get like
It's just like, they're like, almost for like, inner users starting to roll out already. Like, my interview for Raymond James next week, I just think something industry with the
Is there a water fountain on this floor?
There might be one down the hall.
Oh, okay. Yeah.
We also have code.
one of their like talent. So it's like putting one rack but into like that. It's not like a
I never did.
no, I mean, any. That's the one. I got the table. Even when I did it, I last time. I feel silly right now.
I do. I feel like I got scammed, cheated, deceived.
I know
Lied to.
Oh, no. No, yeah, go for it. Don't even worry about me. Literally, later that week, interview with Intel, denied the next day. I feel like, they don't know what they're missing.
So, to be fair, Bloomberg was already,
What company is this?
Oh, well. You win some, you lose some.
Never heard of them.
It's not important. If you don't know what that is, it's not important for us to tell.
but, you know. Sounds like, I feel like now they part of it. But they are the plan to do. All I need to do is just,
But we can get started whenever you're ready, Ryan.
Just wash up and all get started.
Yep.
that's all I need to do. They'll be happy. I made some decisions like you were there a few words. You don't want to follow. Well, overall, and other stuff. Oh, yeah, the averages are really good. These are people, man. You won't think I have to worry about how it's actually like, they need to see what's it all. Oh, there's like a couple weeks of it. Yeah, we got another one. That's like Arch had its benefits. Well, oh, I don't think. I don't have to. I get it again. Okay, so don't disclose. I know most of the story a little. Okay.
Okay, so let's keep going. So, okay. Let me pull up this. I'm gonna pull up SQLite real quick. Just take me a second. Okay, so can you guys read the text in the terminal? It looks like you can. So let's go ahead and is there like a holder for this or something? Actually, let's try this. I'm gonna go ahead. So this base DB file is a database save file. Let's go ahead and open up real quick and just want to show you guys one thing to start off with. So this data right here comprises of the actual records stored in the database. You see, for instance, right here, this is like the total size value of the record, ID of the record. In this case, it's 3. You see here it starts off with 1, 2, 3. Here is the size of the header, which comprises of 2 separate values. The first being a 1-byte integer, second being a string, which we can see that the size of that string is just using that equation that I showed earlier. Should be 5. And when you look at that string, 1, 2, 3, 4, 5, you see that checks out. But for the interesting thing, let's actually, in order to show you this, I need to run SQLite and show you the memory layout. Stevie. Okay, Okay, so one question I have for you guys, how do you guys think that when SQLite looks at a database save file and tries to repopulate a database, excuse me, any guesses on how it does that? Just works roughly? Well, one thing that's a bit interesting is when you actually take a look in GDB at the memory layout, I'm going to just search for one of the strings that is present in the record. Nope. I messed up. Give me a second. Hang on a second. Search. The fun of live demos. Okay, this looks like it should be it. Okay, so here. You guys see this data over here? You see how it's 34, 34, 34, 34, 04? We go over here and we see that data right here, 34, 34, 34, 04. I'm not going to go through it, but basically what I'm trying to show you is the contents of the database save file is exactly the same as the contents of the in-memory database structure. So it literally will just take the database internal data structure, dump it to a file, and then reload it. And the thing that's pretty interesting about this is we can go ahead and, as I'm about to show you, edit this database base DB file, and those changes will actually be affected in memory. And we can effectively control the in-memory data structure of the database. But yeah, I'll go ahead and show that right now. I'm going to be copying actually, any questions before I go on? Okay, cool. Chat. Okay, no. Okay, I'm just copying the base DB file over to a separate file to just overwrite it. And these 5.2s, what ASCII string should I overwrite these 5.2s with? Anyone? Just give me an ASCII string I should overwrite this with, just to show that I can overwrite this. I'm sorry, what? Good idea. Okay. Okay, I'm going to go ahead and load the database save file in. Okay, and yeah. And when we take a look at the hex editor, 61, 61, 61, 08. This. Yeah, 61, 61, 61, 08. So we can see that our changes to the database save file are actually reflected in the in-memory model of the database. Any idea about some of the fun things that we can do with this? Any potential ideas? You. That is true. Yeah, that is a potential route. I'm not sure if SQLite has that particular functionality, but you guys remember going back to the slides. You guys remember this? You see that that header size and variable length size values? We can actually overwrite size values. Now, the question immediately coming next to it is, okay, we can overwrite size values. What does that actually give us? Since in order to do this, we need to be able to read and write from the database save file. Now, what we can effectively do is we can make a SQLite record, expand the size of it, and that way, let's say when we query that record, we can either read or write from subsequent records in memory. And the reason why this isn't just a complete meme because of the attack surface is that the records you're trying to either read or write to might not exist when you're actually able to edit the database file. So that's where the potential for this to maybe come useful actually comes into play. So let's go ahead. I'm going to show you an example of editing a database save file to both leak subsequent records and also overwrite subsequent records. Any questions? Okay. But yeah, how are you gamers doing? Is it a exam week? Okay. Yo, what's up? So something like that, like for instance, like let's say that there is a particular record that you want, it only exists in memory, and also yeah, if you let's say you wanted a record that only exists in memory, this is one potential way. Or yeah, or yeah, if let's say you only have access to like a database file, like at a certain point. I'm mumbling. Am I making sense? Yeah. Like granted, like yeah, admittedly so, like this, it isn't like a major security flaw. It's not like it's a pretty bad attack surface, but like in some weird instances, and especially when I'm going to show that like a lot of different databases, you can actually do a lot of like useful things with this. Like let's say that you wanted, like, I don't know, just for example coming up, you have access to the database save files for a while. You wanted to particularly overwrite someone's password after they make a new account. Something like this could potentially come in handy there. Yeah. So, okay, just making sure I answered the question right. Okay, cool. So let's go ahead. What did I have set for this? Okay, cool. Okay, I'm just gonna. Okay, first I'm just gonna show. I'm working with a database save file right now called leak. I'm just gonna go ahead and just show you the contents of it, of this table. So we can see effectively this database, all of this table holds 5 or 6 records. First, starting with a string followed by a number. Let's go ahead and pop open the leak file in the hex editor. Scroll all the way down to the end. Let's see, what did I have for this? Give me a second. Wait, which? Okay, so for this, I want to be able to make it so that if I query the 3 record, I also get the second or the record with the 2s in it. Now, for this to work, there are 2 size values that I need to expand. There is this value right here, which is the total size of the record. I'll need to expand that. And also the size value of the string, which is this. For this, let's first figure out how many bytes I'll need to expand it by. Right now it's 5. The string ends right here. So we have 6, 7, 8, 9, 10, 11, 12, 13, 14. I just want to leak the first 3 characters of the 222 string. So for this, I'll need to expand the size from 5 to 14. This will add on an additional 9 bytes. So this 09 for the total record size will need to get overwritten to 18, which is in hex 0x12. And then for the size value, right now the size value is, or signifies 5. I need to expand it to 14. And just doing the math for this, it just comes out to be 0x29. And we go ahead and save it. And we're going to go ahead and try this again. Oh, let's try this. So we can see here, when we query the record that's 333, it also leaks out the subsequent 222 following that. And granted, the integer, that's a little bit different since we expanded the size of the string where exactly it's looking for the integer is immediately after that. So the 50 just comes from the data after that. But yeah, as we can see here, we're querying the 333 string, but we're leaking data from this string or this record up here. Anyone do me a favor? Can someone Google what's like the latest version of SQLite just for the fun of it? Let's see. .39. This is on SQLite version 3.4. I think this is like an alpha version or beta version or whatever. But yeah, just showing you that like, yeah, we can query one record. Now let's take it a step further. Let's see, how am I doing on time? I think, okay. Instead of just like leaking a record, let's actually overwrite data. This will be kind of a rudimentary example of it, not super specific, but let's go ahead and show you that. Okay, yeah, the write file is database save file for this instance. Go ahead and run it. Yeah, this database looks kind of similar to the last one. Only difference is it starts off with integer, then a string. And let's go ahead and open up the database save file in this instance. Okay, cool. So we have the records down here now. As to exactly what I want to do, I want to make this that I can update the 3 record and actually overwrite the record that's this 2 record down here. In order to do that, I'm basically going to do the same thing I did last time and expand the size of the record and then update that record such that with this new reported size, the string I updated will be large enough to overwrite this record, but not large enough that it's larger than the new reported size of this record, and in which case I would have to allocate a new record somewhere else, and effectively the overflow wouldn't happen nicely. Any questions? Okay, let's go ahead and do this. So for this at offset, this offset right here, we're just going to overwrite this with from 0.9 to 1.2. That's the size value of the total record that we just expanded. And then there is the size value of the string. We're going to update that from OX17 to OX29. Okay, cool. Now that we saved that, let's go ahead and just load in the corrupted database save file. When we go ahead and see the contents of the corrupted database save file before we do the overwrite, we see that there is a functionality similar to the record leaking from last time. Well, let's go ahead and update that one record. Right now, based on how I'm doing the record overwrite, it actually corrupts the format of the database file, but I'm going to go ahead and actually show you what the database actually in memory search. I want to show you the actual in-memory layout. Actually, that's not working nicely. Let's try this. Okay, cool. Yeah, we can see here the actual in-memory layout of those records. We see the 555 record right here, 444 record, and we see the zeros kind of blend into some of these twos, which is what we're trying to do and have it actually overwrite and overflow it. And now I'm going to show you what the database save file looks like after the overwrite. And yeah, these bytes right here that is 0 is that these are actually some of the beginning bytes of the 222 record. So you can see right here, we were able to update one record, but actually overwrite subsequent records in memory, which I think is pretty cool. Okay, cool. Moving on to the next database implementation. Any questions so far? Okay. Okay, next up, we have a different database implementation called Tokyo Cabinet. I'd kind of be surprised if any of you guys heard it. It's not as popular as SQLite. A bit different though. It's an API database implementation, meaning in order to use this database, you'd have to write C code that calls it. In addition to that, it's based off of a hash map. You guys remember hash maps from CS1? Yeah. This is an example of code that calls it. You just call like, oh hey, Tokyo Cabinet database new, open a file, put in values, so on and so forth. And okay, how many people here, just out of curiosity, have looked at how hash map implementations work under the hood? Cool. This right here is basically the just the how it will actually hash a key. So how records are stored in this database implementation is there are key value pairs. Both are stored as a string. It will take in the key, run it through this hashing algorithm here, which will generate two separate hashes, and then use that to actually find the particular value that corresponds with it. The exact algorithm used to, I'm not going to just spend 20 minutes digging through the code, but it's roughly this. You say, hey, I want to look up a record for a particular key. It will take the key, hash it using basically this Python code right here. Not actually this code, but this Python code basically just does the same thing as the hashing implementation. It will generate a primary and secondary hash. Using the primary hash, it will use that as an index into something it calls the bucket array, which is effectively just a list of pointers to various buckets, which the buckets actually hold the records. When it gets the pointer to, or it actually gets the bucket, buckets in this hash map implementation are actually a binary search tree, which you will use the secondary hash to actually iterate through the binary search tree and locate the actual record. And then once it gets the record, it has it. This is the format of a record in this database implementation. Start off with just a constant value. Then you have the secondary hash value, which corresponds with the actual record itself. Just out of curiosity, why do we need two different hashes for a hash map implementation? Yeah, well, yeah. Yeah, it's specifically for hash collisions. Actually, can someone explain to me what a hash collision is? Exactly. Yeah. if there are multiple records within exactly that, yeah, if there are multiple records within the same bucket, it's because that the primary hash was a collision and they're both the same. But yeah, going through here, secondary hash value, identifying that particular record, the left and right child offset. Like I said, this is a binary search tree where it uses the secondary hash value to determine is it in the left search tree or the right search tree. And then after that, you have the length of the key and the value and the padding, which the padding is just bytes that get added to the end, followed by the actual key value and the padding. Now, for this, for how I go about doing the record leak and overwrite here, it's basically the same as SQLite. I just overwrite those size values that we see right here and here. And based upon that, that allows us to query and overwrite subsequent records in memory. How am I doing on time? Okay. So I'm going to go ahead and give a demo of this now. So first off, let's start with leaking a record. Okay. For this, to use the database implementation here, I wrote two C files, database occurring.c. Actually, let's pop it open so we can actually see it. Box. Okay, can you guys read this? Yeah, it looks readable. Yeah, we basically just open up a database implement or open up a database file. Oh wait, no, querying, my bad. I opened up the wrong file first. Database file creation. So yeah, two files, database file creation.c and database querying. Purpose of database file creation is to effectively create the file, which the database save file for this database, and database querying will actually query it. Look in database file creation. It basically just creates a new database called fighters.z, adds some records in, and then closes the database. Just out of curiosity, anyone watch the new Dragon Ball movie? Okay. Yeah. I'm personally more of a fan of the Broly movie, but oh well. Yeah. Okay, cool. Yeah, database file creation effectively just creates the file, which we will be editing. And database querying.c, when you actually take a look at it, opens up the file and attempts to get the Gohan record from it, and then just prints the value we get from there. So let's go ahead. First, I'm going to delete the fighters.z file and then create a new one. File creation. So that's been created. I'm going to copy fighter Z over to this other file. The reason why I'm doing this copy is just to have a different name for the file. It just makes a little bit more sense. This leak fighter.z is the file that we're actually going to be editing to do the fun things. And we go ahead and pop open leak fighters.z in a hex editor. And we scroll all the way to the bottom, and we are actually seeing the records here. Going back to back to the slides, the value of the key and the value are stored side by side. We see here the key is Gohan and the value is Kamehameha. We see that the size value for Gohan is 5 and the size value for this Kamehameha is 10. So effectively, I want to make it that when I query the Gohan record, I get the Piccolo record. So effectively, what we can do is this OA value. Let me just make sure I'm doing this right. Actually, taking a step back first before I do this. Got it a little bit ahead of myself. I want to show you what it's like when we query this database prior to actually corrupting the database save file.
Okay. RX. So yeah, this is the result of querying the Gohan record, which should just be Kamehameha. You see that effectively it is just that string with a bunch of nulls after it. That is not displaying nicely. Okay, yeah, we see it's just the Kamehameha string. Looks like some heap metadata after it. Now that we saw that, I want to go ahead and overwrite the file now. I'm going to overwrite this, expand it from OX0A to OX2A. Save it. And when you go ahead and try to query it again, we'll look at the memory layout in GDB. Oh, we see that there's extra, looks like there's extra data after it that wasn't there before. And when you go ahead and just look at it as a string, I did not do that copyright. The marvels of working on a touchpad. We see that it's the start of the finger thing, which is the value of the Piccolo record we are trying to leak. So we can see that by querying the Gohan record with this modification, we are actually able to leak data from subsequent records in this instance. So that's it for that demo. Next, let's go ahead and in this instance show us how we can use this to actually overwrite a value in this particular database implementation. Any questions before I continue going on? Okay, cool. What are the use cases for Tokyo or for this database implementation? Well, taking a step back, it's a hash map database implementation. So you get that O of 1 runtime whenever you do a record lookup or deletion. So I'd say in instances where you're perfectly fine with the values being strings and you also want a lot of performance gain, this would be a better instance because I know other database schemas, ones that like run off of records where it's like, oh, hey, I have like a million records in this table. I want the one with ID 5,000. You're gonna have to scan through all of them. So I would say it's in instances where you want to use a database from the perspective of a C application where performance is. Yes, however, on a lot of instances, I would imagine that's like, oh, hey, let's say you have a C API that is like, I don't know, a game server where you can like look up stats for someone. I would imagine that in any like realistic application, there probably will have some ways to actually like, oh, hey, I want to make this particular query for it. That being said, this particular database implementation, there are a million out there, and this probably isn't going to work for a lot of them. But kind of one thing I wanted to do with this particular project was look at a lot of different database implementations and see like if this type of thing is actually possible with a lot of them, because that's when it gets a little bit more interesting, in my opinion. Did I answer your question? Cool. So overriding. Okay. For this, we have 3 separate files. Database file creation, which effectively we see here, it will just create a new database for us, insert some more records that are Dragon Ball references, and then close the database. For database insertion.c, we see that it will effectively will just add in the value for the Gohan record to be the super long Kamehameha string. Also, for this database implementation, if you're trying to insert a record or into a key that already exists, it just acts as an update. And for database querying,
we see that it's effectively just trying to query the Piccolo record and then print that if it can. So let's go ahead and go through this. I'm going to go ahead and make the database save file now. Copy it over to the overwritten fighters.z, which is for the file that we will actually edit. Okay. So the Gohan record is the record that we're actually going to update and overwrite the subsequent records with. So for this, we will change the size value right here from 0A to 6E. Save it. So first, let's go ahead and try to query the Piccolo record, see that it exists. Yep, exists right there. We see the value right there. Update the Gohan record. So this Piccolo record should now be overwritten. Try to query the non-existent Piccolo record, and we see that it doesn't, there's nothing there. And when we take a look at the database save file again, we see that, yeah, in this instance, it did actually overwrite all of those records with this string that we inputted. Also, one thing I probably should have said earlier, in this database implementation, similar to SQLite, where the actual contents of this database save file is the same as the in-memory database structure. And yeah, 706. I forget, when did I start? 610? 620?
Oh, yeah.
Okay. Roughly how much longer do I have? Okay, cool. I can show one more thing then. Okay. So next up, there's a database implementation that's a little bit differently. Okay, 706 until 716. This is WhiteDB. It's another database in API, but it differs a lot in the actual format from the previous two. In this particular database, values within records are stored in 8-byte values called GINTs. Records can have different numbers of fields, and yeah, all values are stored within these GINTs. For this, there are really two different types of data encodings that we need to concern ourselves with this. The first is if it can fit within those 8 bytes, it will just store the value in it. So let's say if we're trying to store the value 0, 1, it will just store that in the GINT. And when it can't, it will instead store effectively an offset to that data within that value, and it basically treats it as a pointer. This is a list of all the WhiteDB data types, but I'm not going to be going into that right now because of time. And for record leaking, because of that record or values can be encoded as effectively a pointer and that we can overwrite that. Any idea about fun things that we can do? Yeah. In the beforehand with the previous two database implementations, while we could only leak data that was relative to the actual record, in this instance, we can actually just overwrite that with a pointer to anywhere else in the database and leak data that way. Of course, this is an offset to the start of the database file, so it is relative to the database, but we can leak data that is OX 100 bytes before it. And now I'm going to try to run through a demo of this before I end. Okay, for this, it is another databasing API similar to Tokyo Cabinet. In here, I'll just effectively create a database with 2 strings. Anyone here listen to Shinedown? You might recognize these lyrics somewhere in the stratosphere or have to think twice. Yeah, effectively just creates this file right here, leak db file 0.
And then we have the leak records.c file, which will effectively just query for all of, I believe, yeah, all of the records within the database save file. Then go ahead and run leak record. Oh, wait, I forgot to copy over the file. And similar to the other demos, the file that is being created is a different name than the file that is being read from for the actual database leak. So I just copied over the file that was created to the corrupted file. And when we run leak records, we see that it prints off the two strings here. So let's go ahead and pop open the database save file. So for when this database implementation goes to actually store a particular value, it doesn't store that exact value. It first encodes it. For the records that I inputted, I had the value 5 inputted into them to make it easier to search for. With how I'm like, don't have the time to go into it, but with how this database implementation will actually encode particular values, those values will get, let's see. Oh, wait, wrong demo. Those values will get encoded as OX0283, which, because this is least Indian, actually, can someone tell me what least Indian is? Yeah. Or little Indian, same thing. Yeah. I just call them both. 302. It's basically a byte order for things is like, it's least significant byte first. So if you had like, just imagine that the bytes are backwards. But yeah, here is the contents of the two records right here. We see that there's the first offset is 011756. Second offset is 011776. The 6 value at the end, that's a part of the encoding. The actual real offset is 011750 and 011770. And when you go ahead to those, OX 011750, we see that it's the two strings that we actually wanted to print it. So let's go back. I forgot what the offset was for the pointers. Yes. So I want to go ahead and overwrite this particular pointer to give me, just want to edit the first pointer to point to the second pointer right here, the 011756, and just leak it that way. For that, I can just overwrite, let's see, this with A6 B700. Why did I overwrite it with OX B7A6? That's because this offset right here, we can see it right there as B7A0. So we go ahead and save it. And where's my cursor? There it is. Okay, I'm gonna break right at the printf so I can see exactly what the value being printed is. So we see for the first instance, for the first record, because we did not modify that pointer, it's somewhere in the stratosphere that's being printed. But when you go ahead and hit the second one, you see that's, oh, hey, it's that pointer that we overwrote the second record to reach 1775 or 011756. And yeah, we see that we could literally modify a pointer within a database file, and we can just query that record to literally query any piece of data within that database. Any questions? Cool. Yeah, with that, I'm probably going to end it here. I probably didn't even get to cover like half the database implementations I looked at.
If you want more, I'll post a link to the project where I documented all of this stuff on Discord. So you can check there, or you can just come talk to me. And also one thing I will say, if doing this type of hacking, but on actual useful attack surfaces, so these exploits can actually be really used in that stuff, interested you at all, come talk to me. I work for a cool company that does that type of work. Yeah. But yeah, with that, I am going to end it. Yeah.
Okay.
Appreciate anything to check out here.